Welcome to Special Ed Hub. Today we're diving into the fascinating world of electric current and its many effects. It's all around us, making our lives easier and more interesting. From the lights in our homes to the phones in our pockets, none of it would be possible without the power of electricity. Let's get started. Have you ever wondered what's happening inside those wires when you flip on a light switch? It's all about electric current. You see, everything around us is made of tiny particles called atoms, and these atoms contain even tinier particles called electrons. Now these electrons, they love to move. Think of it like a river, but instead of water flowing, it's these tiny electrons moving through a wire. That flow, my friends, is what we call electric current. And where does this current come from? Well, it needs a source, something to push those electrons along. That's where electric cells come in, like the ones you find in your TV remote or a flashlight. These cells act like pumps, giving those electrons a push and creating the flow of electric current. Pretty neat, right? Now we know that electric current is the flow of electrons, but did you know that some materials are better at letting those electrons flow than others? It's true. We call materials that allow electricity to flow easily conductors, and they're like the superhighways of the electrical world. Metals like copper, aluminum, and silver are excellent conductors, which is why we use them in electrical wires. On the other hand, we have insulators. These materials are like roadblocks for electrons, making it very difficult for electricity to flow through them. Think of things like plastic, rubber, wood, and glass. They're all great insulators. Here's a helpful tip. Most metals are good conductors, while many non-metals are good insulators. Keep that in mind next time you're handling electricity. Remember those electrons flowing through a wire? Well, all that movement creates friction, and friction, my friends, generates heat. That's right, electric current can make things hot. Think about the filament in a light bulb. When electricity flows through it, the filament gets so hot that it glows brightly. The same thing happens in an electric heater. A special wire called a coil heats up when current passes through it, warming up your chilly room. Want to see this in action? Try this simple experiment. With the help of an adult, carefully connect a thin wire, like the kind you find in a light bulb, to a battery. Watch as the wire glows and heats up. It's a real-life demonstration of the heating effect of electric current. Chapter 4. The Magnetic Effect. An Invisible Force. Electricity is full of surprises, and here's a big one. When electric current flows through a wire, it creates an invisible force field around it. A magnetic field. That's right, electricity can act like a magnet. This amazing discovery was made by a scientist named Hans Christian Ørsted, and it changed the way we understand electricity forever. He found that a compass needle would actually move when it was placed near a wire carrying electric current. You can try this yourself. With adult supervision, set up a simple circuit with a battery and a wire. Bring a compass close to the wire, and watch as the needle is pulled by the invisible magnetic force. It's like magic, but it's science. Chapter 5. Electric circuits, the pathway of electricity. To make electricity useful, we need to create a path for it to flow. That's where electric circuits come in. Electric circuits are the backbone of all our modern electrical devices. Without them, we wouldn't be able to power our homes, gadgets, or even the lights in our rooms. Think of a circuit as a loop or a pathway that guides the electric current to where it needs to go. This loop must be complete for electricity to flow. If there's a break anywhere in the loop, the current stops and the circuit won't work. Let's build a simple circuit. This will help us understand how electricity flows and how we can control it. We'll need a few key components. A battery to provide the electrical push, which is also known as voltage. The battery acts like a pump, pushing electrons through the circuit. A bulb to light up, which will show us that the circuit is working. The bulb converts electrical energy into light energy. A switch to turn the circuit on and off, giving us control over the flow of electricity. When the switch is open, the circuit is broken, and the current stops. When it's closed, the circuit is complete and the current flows. And some connecting wires to act as the pathway. These wires connect all the components together, allowing the current to flow from the battery, through the bulb, and back to the battery. Now let's draw a circuit diagram to represent our creation. Circuit diagrams are like blueprints for electrical circuits. They help us visualize and plan our circuits before we build them. We use symbols to make it easy to understand. These symbols are standardized, so anyone familiar with them can read and understand the diagram. A long line represents a wire, which is the pathway for the electric current. A circle with a cross inside represents a bulb, showing where the light will be in the circuit. and a line with a gap represents an open switch. This indicates that the circuit is incomplete and the current cannot flow. When the switch is closed, we use a dot to show the connection. This means the circuit is complete and the current can flow through it. See if you can follow the path of the electricity in our circuit diagram. Start from the battery, move through the wires, pass through the bulb, and return to the battery. This continuous loop is what makes the circuit work. Chapter 6. Sometimes we need a little extra power, and that's where connecting multiple batteries comes in handy. By connecting them in a special way called series, we can increase the total voltage, which is like giving those electrons an even bigger push. Imagine you have 3 electric cells like the ones in a flashlight. To connect them in series, we connect the positive end of one cell to the negative end of the next cell. We continue this pattern until all the cells are connected in a line. When we connect cells in series, the positive end of the first cell and the negative end of the last cell become the main terminals of our battery powerhouse. Now we have a battery with 3 times the voltage, ready to power up our devices. Chapter 7. Remember how we learned that electric current can create a magnetic field? This fascinating phenomenon is the foundation of electromagnetism, a principle that has revolutionized technology and industry. From electric motors to MRI machines, electromagnetism is everywhere. Well, we can put that knowledge to work by building our very own electromagnet. This simple yet powerful device will help us understand how electricity can be harnessed to create a magnetic force. It's a magnet that we can turn on and off with electricity. How cool is that? Imagine the possibilities of controlling magnetism at the flick of a switch. This is the magic of electromagnets. Here's what we'll need: an iron nail, which will serve as the core of our electromagnet. The iron core amplifies the magnetic field created by the electric current. Some insulated copper wire. The insulation keeps the electricity flowing in the right direction, ensuring that the current doesn't short circuit and that the magnetic field is generated efficiently. And a battery for our power source. The battery will provide the necessary electric current to create the magnetic field. First, we carefully wrap the wire around the nail, making sure to cover as much of the nail as possible. The more coils we have, the stronger the magnetic field will be, making sure to keep the coils close together. This ensures that the magnetic field lines are concentrated and the magnet is more effective. Next, we connect the ends of the wire to the positive and negative terminals of our battery. This completes the circuit and allows the electric current to flow through the wire. And voila, our nail is now magnetized. The electric current flowing through the wire creates a magnetic field around the nail, turning it into a magnet. Hold it near some paper clips or small iron objects, and you'll see the magic of electromagnetism in action. And watch as they are pulled towards the nail. This simple experiment demonstrates the powerful relationship between electricity and magnetism. We've created magnetism with electricity. This principle is the cornerstone of countless technologies that we rely on every day. From household appliances to advanced medical equipment, electromagnetism is a fundamental force that shapes our world. Chapter 8. We've learned so much about electricity, but the real magic happens when we see it in action all around us. Electricity is the lifeblood of our modern society, seamlessly integrating into every aspect of our daily lives. From the moment we wake up to the time we go to bed, electricity is there, making everything possible. From the simplest devices to the most complex machines, electricity plays a vital role in our modern world. It powers our homes, our workplaces, and even our modes of transportation. Imagine a day without electricity, no lights, no internet, no smartphones. It's almost impossible to fathom. Think about the everyday objects we use. Flashlights, TV remotes, and toys. They all rely on electric cells to function. These small but mighty power sources ensure that our gadgets and gizmos are always ready to go when we need them. Toys in particular bring joy to children and adults alike, all thanks to the power of electricity. Whether it's a remote-controlled car or a talking doll, electric cells make playtime more exciting and interactive. And what about the appliances that make our lives easier? Electric heaters, water heaters, and toasters all use the heating effect of electric current to do their jobs. These appliances provide us with warmth, hot water, and delicious meals, enhancing our comfort and convenience. The heating effect of electricity is a marvel in itself. It allows us to cook our food, heat our homes, and enjoy hot showers. Without it, our daily routines would be much more challenging. And don't forget about motors and fans. These devices harness the magnetic effect of electricity to spin and create movement. From ceiling fans that keep us cool to industrial motors that drive machinery, the applications are endless. They harness the magnetic effect of electricity to spin and create movement. Motors are the backbone of many industries, enabling production lines to operate smoothly and efficiently. Even those giant cranes used to lift heavy objects rely on powerful electromagnets. These electromagnets generate strong magnetic fields that can lift and move heavy materials with ease, revolutionizing construction and manufacturing processes. Electricity is truly a remarkable force that powers our world and makes our lives better in countless ways. It illuminates our cities, connects us to the world, and drives innovation. As we continue to advance technologically, the role of electricity will only become more integral, shaping the future of our society. Thanks for watching. We've explored the amazing world of electric current, from its ability to flow through circuits to its power to generate heat and magnetism. Remember, electricity is everywhere, and understanding how it works helps us appreciate the wonders of science and the world around us. If you enjoyed this electrifying adventure, don't forget to give this video a thumbs up and subscribe to Special Ed Hub for more exciting content. Keep those brains buzzing, and we'll see you in our next video.